Hello and welcome to this video. We are going to be discussing polynomial graphing and factors and zeros. In part one, we are going to be looking at the connections between factors and zeros when it comes to those polynomial graphs. By the end of this first part, we're looking to be able to find the zeros of a function from its factored form and kind of look at how that factored form affects what the graph itself will look like. So we now are looking at three different graphs with their functions to go along with it. So I want you guys to think on your own as you're watching this and looking at graph number 1, number 2, and number 3, and think about what you notice or wonder about any of these three graphs or functions that we look at in front of you. No real wrong or right answer here. We're just looking for observations, and you'll have a way to state those observations after you kind of finish looking at these. So take a little bit to look at all three of these. Just some quick observation on things you might notice. They kind of point, the arrows in both directions point down and then up for all three of these, so they have that in common. They all have three x-intercepts and only one y-intercept. They have that in common. And they also all have three factors, 1, 2, 3 factors for all of these functions. And you might have some different observations or things you might wonder about after you've thought about these three functions and graphs too. So in this slide here, we have some different examples of the factored version of a bunch of polynomials. And a lot of these kind of work in the same way. So we're going to kind of do a couple of these. So as we go through it, you should maybe pause the video now to see what x values would make this true. So and we'll do a couple of them together as well. So for starters, in number 1, we should note that these all have three factors. So if you are trying to make the equation true and have it equal 0, since this is all multiplication, each one of these different parentheses could equal 0. And if that's the case, the whole thing would end up being equal to 0. And so for this particular problem, number 1, I can find three different x values that would make the whole function equal to 0. So the first one would be -4. So if I put in -4 into all those x's, I would have -4 plus 4. And then I would have -4 plus 2. And I would have -4 minus 1. And in theory, all of that should be equal to 0. Now, these second two parentheses, well, that would be -2, and this one over here would be -5. So -2 times -5 would be positive 10. But then this first one, -4 plus 4, ends up being equal to 0. So we figured out that one value was -4. So if we kind of get rid of that and start over here, you basically are going to do that with each of these parentheses. Whatever makes each one of these parentheses equal to 0, well, that would mean that the x value would be the one we're looking for. So we already figured out that x equals -4 would work for this one. So if we look at just that second parentheses, if we take what's inside of it and set it equal to 0, well, I would see that, well, x is going to have to be -2. And if I put -2 into this middle parentheses, that would make that one 0. And then I could look at the last parentheses. And so I have x minus 1 equals 0. And that's for this one. Well, that means that x is going to have to be equal to 1. So it turns out that -2, 1, and then the -4 we had before are the three values that would make number 1 equal to 0. That is going to be very similar to number, let's mark these. So if you kind of look at number 2 and number 4, those are both pretty similar to the one we just did. And you might want to pause the video and try those out. For instance, they would have, this one, number 2, would have the same ones, but since x minus 3 is on the end there, that would mean that 3 is another number that would make this last parentheses equal to 0. Some other ones we want to point out is number 3. We have parentheses that have been squared here. So we've talked about parentheses in general before, in that when you have a parentheses squared, just remember that you're doing like x plus 4 parentheses squared means that you're doing x plus 4 times itself. So we have that times another x plus 4. And then you have 2x plus 2's. So if we have those all kind of expanded out like that, just like we did before, we can set each of these equal to 0. So we would have x plus 4 equals 0. And we have x plus 2 equals 0. And so that would just mean that for number 4 here, we would have x equal to negative 4 as an answer, and x equal to negative 2 as an answer. And the negative 2 in the front is not going to affect this because there's no x to put in with this negative 2 right here. So in number 4, it's kind of just the same thing as the previous problems. And same thing with some of these other ones that we can look at real quick. So for number 5, for instance, we can still make each one of these 3 parentheses. We can set it equal to 0. So for instance, I could take 7x minus 3 and have that equal 0. And so I just need to do a little bit of solving equations and see that x is going to end up being equal to 3/7, which you could turn into a decimal if you prefer that. So you can see decimals down here. And then that's one of those x's. So you would find out, well, from x minus 10, you would know that one of the x's is also a 10, positive 10. And then 2x plus 8, you would do the other part. 2x plus 8 equal to 0. And if you solved that for x, you'd end up with negative 4 as one other answer. And you can always check that by putting your x in. 2 times negative 4 plus 8 would equal 0. So another one there that made the whole thing equal 0. So otherwise, number 7, kind of the same thing. And then we have the last ones of 6 and 8 that we're going to talk about. So for number 6, we have something that's written in standard form. And we would want to factor that quadratic. So think back to your factoring skills. That would factor into x minus 4, or x plus 4, I mean, and then x minus 1. So you would kind of figure that out first. And then you would see, well, I'm looking at x plus 4 and x minus 1. So the two x's that would make this all 0 would be negative 4 and positive 1. Now, the last one is number 8. It's a little weird, but we can still use the same strategy. Set whatever is inside the parentheses equal to 0. And just solve for x. So we use a little bit of our quadratic equation solving skills, and we would figure out that x squared equals 4 means that negative 2 and positive 2 would both be answers, since you could put either of them into x squared and then subtract 4 to get 0. And then the x plus 9 part would just tell me that x equals negative 9 would also be one of those numbers as well. Essentially, this strategy is to look at each factor and set each factor independently equal to 0 and solve for x. Your answer would be a number that would make the whole thing 0, since it's all multiplication. And you can apply that rule to all 8 of these problems. So moving to our next part. So if you were in class, we're going to be doing a matching activity, and I will show you guys, and I will post the cards that you're going to be matching. But basically, you're just trying to match an equation with a graph and use what we've talked about as far as kind of looking for explanations of why you think one matches the other. And we're trying not to get too in depth with zeros and factors yet. You're just using your skills you already know about graphing to kind of match them up. So let's kind of just look at one matching card part only together right now. So for instance, in card A right here, we have x minus 5, x minus 4, and 2x plus 3. So you could kind of graph that and try to match it up. But something to remember is that we have x minus 5, x minus 4, and 2x plus 3. So using our strategy from the last slide, we'd be looking for a polynomial with our zeros as 5, 4, and then negative 3 halves. And then you would just be kind of scrolling through these and looking for where you have these three numbers as your x-intercepts. So if that's close, 5, negative 4, and negative 3 halves, that's close to what we have. And you can kind of explore through that. So like this one, 4, 5, and negative 3 halves would match this right here. So card A ends up matching card 4. But this is something you can explore on your own with the what I will post in Google Classroom for you guys. And we can move to our next slide now. So to kind of wrap this up, I'm just going to kind of explain how you identify what values of x make v of x equal 0. So something important here, when it says make v of x equal 0, the values of x that equal 0, that is when you have x-intercepts, or when y is 0, since this is basically equal to y. So just remember that x-intercepts happen when y is 0. So any x value that makes this whole thing equal 0, those x's are going to be the ones that are going to be your x-intercepts because they make y 0. And we're using the same strategy as well for doing 11, for figuring out each of these three parentheses. So we are going to set what's inside of each factor equal to 0 and solve for x. So we would have 11 minus 2x equal to 0. And that means that x is going to be equal to, looks like 11 halves. Positive 11 halves. And then we have 8.5 minus 2x. We can set that equal to 0. And that means that we would have an x value there. So if we added 2x, we would just be doing, or no, we have an extra x there. So we would just need to do that quick division there. So we would just be doing 8.5 divided by 2 and getting 4.25. And then the last one, something to look out for, when you just have x as a factor, that means that this x right here is just going to be 0 automatically. And that's something to remember for future problems. And that's how you would kind of find all the values when y is 0 or v of x equals 0. And just remember that all those x's you're finding, those are your x-intercepts, or your zeros in the way of saying it. And so now we have a kind of a wrap-up problem you guys are going to try on your own in a second, but just kind of read through it together. Polynomial y equals x minus 5 times x minus 2 times 4x plus 3 has been graphed incorrectly. Identify the error and how to fix the graph. So take a moment to try this problem out and see if you can find the error and how to fix it. So the error is they've kind of used the opposite signs of what you're supposed to. So from x minus 5, you would set that equal to 0 and figure out that your x-intercept is 5, and then you'd have 2, and then you'd have your last x as negative 3 over 4. So if you look at the graph, we have the exact opposite of that. We have negative 2, negative 5, and positive 3/4. So that's the danger you want to be careful of, is that when you see x minus 5, the minus 5 part is not the x-intercept. The 5 that would make this whole thing right here, this factor 0, is what you want to use instead. And that's something to be careful about. So this graph would kind of move so that we have these three x-intercepts I outlined above instead of the opposite sign ones we have in the problem below. And that is where we will end part 1 of this lesson.